Look, the highest degree or the power of x, the degree of this expression is 2. So I'm going to multiply this entire x plus 1 by x. And I write it here, which will mean my quotient, which you have heard a lot, perhaps would be over here. So try and multiply this x with this x as well as this 1. See what do we get. So what we get is x square plus x. Put a minus sign, which means you're doing x square minus x square. Same terms cancel out. You're doing 3x minus x, plus and minus, minus is overpowering. So 3x minus x. And what you do essentially is you get the answer as 2x. Whatever terms are remaining, you bring it over here, you get 2x plus 2. Now this will approach it in a similar way. Here you have 2x, which means that if I try and multiply with a positive 2, which means positive 2 multiplying by x, and then there are two terms here, don't forget. Positive 2 multiplying by 1. So what you get over here is 2x plus 2. Okay. Now, do you notice that whatever you've gotten so far, which is 2x plus 2 and 2x plus 2, of course, with a minus sign, are similar in nature, so you can actually cancel out. And what you get is the beautiful 0. And why beautiful 0? Because that's 100, 100. You understand, right? 0 is power of 0. Okay, jokes aside, you get a 0 and we'll call it the remainder being 0. Now, this also indicates that this expression x plus 1 is actually able to completely divide x squared plus 3x plus 2. So you can actually write this expression as this divisor into this quotient, right? How will it look like? Let me show you. You can write this expression. So I'm going to take this expression. I'm going to write it as, let me just erase this part. Yeah, so I'm going to write this expression as x plus 1, okay, and x plus 2. And this will complete it because essentially what I've done is I've tried to convert them into two factors. And it's also part that we learn in quadratic expressions that we can convert into two factors. Okay, but I'm not convinced yet. Let's say if I change this to 4, what happens then, right? And this could be a valid question. If you change this to 4, sorry, uh, where do you think the impact will be? Will the impact be in this, or will the impact be in the case of remainder, which was 0, right? Just take a moment and reflect as to what you think the impact would be. Okay, so let me tell you the answer. Uh, See, the impact is going to be here because this 4 will now be carried forward. Okay, just you do the same exact same procedure, but this 4 is going to get carried forward. And what happens is that 4 minus 2 will give you 2, which means the remainder in this case will be 2. So if I want to write the new question, I'm going to write it as x plus 1 into x plus 2, but then I will have something as the remainder, which is plus, what's the remainder? It's 2. Okay. Uh, so you can actually write it even in this fashion. What was the divisor? This, what was the divisor originally? It was x plus 1. So you're going to write it as 2 into x plus 1. Of course, you can cancel out this, but this 2 is the remainder, so you can't really cancel out. And this is your answer for this question, where when you change this to 4 and you divide, what you get is this expression itself. So this is how long division typically works. You take the divisor in this part and you look at what is the highest power of x starting from the first, this left hand side. And then you write something in the, you write whatever is required for you to cancel out this particular first left hand side first term. And then you continue one by one to eliminate till you get a remainder, which is not really possible to multiply with something and eliminate. Can you tell me when is that possible? When do you think that case would arise? Where you get something as the remainder, but then you can't write something in the quotient to be able to cancel out. Okay. Yeah. I'll tell you one example where that can happen. Imagine that you're dividing a polynomial, and instead of x plus 1, what you're dividing with has some uh, degree itself. So it can have something like x squared. Now, suppose you have x plus 1 left after some steps, and then you're dividing by x squared. You think you'll be able to divide this? What do you think? What's your answer on this? Okay, so take a moment to think. Okay, I'll tell you one hint in the form of a. So I got one story to tell you. Let's say you play basketball or you play some sports. Uh, you have a team also swimming. You have a team, and you get some 30 bananas for your team members. And if I tell you, okay, you got 30 bananas, so you've gotten, let's say, you've gotten what? You've gotten 30 bananas. Okay, this is just an example to give you some relation with this part, but this, of course, is dealing with x and power of x. But here we are dealing with numbers, so it's another very simple one. Now you want to tell me how many dozens you are going to buy. Okay, so 30 upon 12, because the dozens means that it has to have 12 units, which means you will have two bananas, or you can say 2 into 12 plus the remainder. So it so happens that you just cannot divide 6 by 12. So you're going to write 6. And that is one way of looking at this number 30. It's 2 into 12 plus 6. Similarly, in this case, when the power is 2 and what you're dividing has a lesser than 2, which is in this case true, then you just can't divide. This will now be going into what we call as the remainder. Okay. So I hope you liked it. I had a good time. Thank you for watching.